this is really a graduate level course. Okay, this is a graduate level course, and as defined above, it involves advanced numerical methods for solving the Navier-Stokes equations, numerical solutions to a boundary layer problems, solution of potential flows, and computational heat transfer. Now, how many of you have taken a numerical analysis course? So you see that what we are going to do is actually the application of what we learned in numerical methods, okay? Numerical method is just, you have an algebraic set of equations, and you use a methodology such as the Gauss-Seidel or the Thomas algorithm, if you remember, or other tri-diagonal matrix systems to solve that numerical problem, okay, to obtain the solution. Well, basically, what we are saying that in fluid dynamics, we have our governing equations that form the fluid dynamics, right? We are going to cast them in a form that will be solved numerically instead of obtaining exact solutions for a number of different cases. I don't have a textbook. Well, I have one book here with me, okay? But for references, if you go back home, or you go back to your dormitories or your apartments, these are some of the textbooks that you can reference, okay, for what I'm going to talk about. Okay, these are all books that you can reference for what I'm going to talk about. In fact, the background of, or I should say, one of the fathers of computational heat transfer is Professor Suhas Patanka, whose finite volume approach has been the basis for the Fluent ANSYS CFD software. I asked you questions about your background. So you see that some of the prerequisites to fully understanding the CFD course involves vector differential calculus, the basic knowledge of fundamental fluid dynamics, okay, understanding of the application of conservation of mass and momentum in fluid flow systems, understanding of the application of conservation of energy in thermal systems, okay? That is why I asked about your background, okay? So since you informed me that you've taken all these courses, I know that you are well prepared, and I do not need to go back to the time when you were teaching these courses. However, if you have any questions at any point during this lecture discussions, of course, raise your hands and ask the question. The overall objectives are to demonstrate through report writing, oral presentation, and proposal development skills through projects that will be offered in the class. Well, yes, in our graduate level course, we expect you to do some project at the end where you would present what you've done pertaining to this course, that is the computational fluid dynamics. I'm not going to expect that of you, okay? But I'll be giving you assignments. You should be able to categorize partial differential equations as either elliptic, parabolic, or hyperbolic, okay? You should be able to solve numerically It's back? Okay. You should be able to solve numerically the governing partial differential equation for any flow problem, whether it's in 2D or even in 3D, okay? Know the solution process of CFD problem in general, okay? Well, we don't have a license for the ANSYS software here, I'll make references to it. But knowing what you know from what we are going to go through here, that should give you a firm understanding of what takes place in the background when you are using softwares such as ANSYS, COMSOL, FlowBench, and other softwares that are used to solving CFD-related problems, okay? So at the end of the day, you should be able to develop problem-solving skills in CFD through continual testing and problem assignments. Now, Dr. Boachi indicated that, you know, within our Carnegie-funded project, we are going to work on how aerosols impact the climate, okay? Impacts the environment. Well, you see, I'm also doing continual problem solving and learning, because through this project, it's giving me the ability, or it's giving me the opportunity to basically apply my CFD background to his climate science. Traditionally, I have applied my CFD background in the solution of materials-related problems in heat transfer, and also in fluid-related problems in multi-phase flow, okay? So, you know, the expectation is that this is not be the end-all, or, you know, after we go through the process, but it will give you the ability to basically keep learning, okay? A lifelong learning process. This is typically what we would capture or go through in a given semester. We are going to start over here, do the general introduction of CFD. We will also go through the solution procedure, a beginning governing equations for CFD. We'll talk about some of the mathematical